Chapter 5, Activity 2A, Transverse Waves. So Activity 2 is broken into two parts, transverse waves and longitudinal waves. So transverse waves are waves that have crests and troughs, peaks and valleys. Okay, so this is a good example with all of the parts of a transverse wave. You have your wavelength, which is typically measured from crest to crest. Okay, your crests are your high points, so there are 3 in this example. Troughs are your low points. There are 3 in this example. Amplitude is the distance, it's the displacement from the original position. So amplitude is the distance from a crest to the midpoint. It can also be from the trough to the midpoint. These will be the same. And then this shows you one wave. One wave is one complete cycle. So if you're starting here, we're starting at the midpoint on the way up. So that's midpoint on the way down. And then we're back to where we started, midpoint on the way up. So that would be considered one wave. Transverse waves are light waves. That's the way light travels. And the direction of the wave is perpendicular to the direction that the energy is moving. So perpendicular is at a 90-degree angle. So if the energy is traveling, the wave is traveling this way, then it's moving at a 90-degree angle as it's headed in that direction. Okay, so you use the diagram below in order to answer questions 1, 2, and 3. Okay, the wavelength of the wave in the diagram above is given by, so wavelength is typically, most obvious is crest to crest, so that would be A. The amplitude of the wave in the diagram above is given by, if you remember, amplitude was the distance from, it's the displacement from the midpoint. So it can be from trough to the midpoint. It could also be from the crest to the midpoint, but that's not one of your options. So it's going to be D. So the amplitude is D. Okay, and then 3 asks you to indicate the interval which represents one full wavelength in the diagram to the left. One full wavelength is one complete cycle. So if we're here, we're starting at the midpoint on the way up. We go through one complete cycle. That would be one wave. If we start here, then we're at the midpoint on the way down. So we would have to go until that same thing is happening again. So that would be one complete cycle. So based on your choices, A to C, from A to C, that is half a wave. So that's not correct. B to D, again, it's half a wave, not correct. So you haven't had one complete cycle. A to G is, that's 1 1/2, so that's not correct. So if you look at D, D is from C to G, which is, we start at the midpoint on the way down, and we finish at the midpoint on the way down. So D is the correct answer. So you were given a set of 3 waves with some directions for measuring those waves and identifying different properties of those waves. So this is just practice to make sure that you understand the different parts of a transverse wave. So the first thing is you're supposed to count the number of crests. The number of crests are the high points. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 crests. Crest again are the high points. Then for column B, you were asked to count the number of troughs. Troughs are the low points. So 1, 2, 3, 4, 6, 7, 8, and 9. So there are 9 troughs. Now, are they always going to be the same? No. Are they oftentimes going to be the same? The number of crests and the number of troughs? Yes, but they do not have to be. So amplitude, if you remember, amplitude is the distance, it's the displacement from the midpoint. So amplitude would be the distance from the midpoint to the crest. And so you need to just take your ruler, put it on there, and you would measure this distance. And it should be around 1 centimeter, give or take a tenth or so. So wavelength again, for column D, wavelength is the distance from crest to crest. That's the most obvious, that's the easiest typically to measure. So you put your ruler and you measure the distance from one crest to the next crest. So you measure that, and that's going to be about 2 centimeters. Okay, and then you're going to count the total number of waves. Okay, and again, it's how many total cycles that happen. So, and we're saying that this picture is 1/10 of a second. So this is how many waves happen every 1/10 of a second. So if we start here, okay, that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 vibrations. So there would be 9 waves for this particular case of 1/10 of a second. Now to find the frequency, there's a lot of different ways to find the frequency. And this is just some practice to give us, to try to make it more meaningful. But so this is how many waves. There are 9 waves, we said, that happen in 1/10 of a second. So there are 10 tenths in a second. So you take your 9 and you multiply it by 10, and that's going to give you the frequency. So 9 times 10 is 90. So that's going to go here. So it's 90 hertz. Then the last thing I ask you is wave speed. Okay, wave speed is frequency multiplied by wavelength. So this is the symbol for wavelength. And in this case, our frequency is 90. It's here. 90 hertz. And then we're going to multiply our frequency. So column F, frequency times wavelength, so column D. So you're going to multiply these two columns. Wavelength times frequency will give you wave speed. So 90 hertz times 2 centimeters. Okay, 90 times 2 will give you 180 centimeters per second. So we'll put our 180 here. And then that was for wave A. You had 2 other waves that you needed to do the same thing for. Follow the same steps. They're different size, different number of waves, amplitudes different, wavelengths different. So you have to measure all of those. So, but you follow the same steps, and the directions to find each column is on the previous page in your logbook. So this activity 2A wrapped up with one question. Look at the 2 waves below. As wavelength increases, what does frequency do? So as wavelength increases, what happens to frequency? Well, if you look at the wavelength here, it's pretty short. So we're starting with this wavelength, and then it's going to increase to this wavelength. So as wavelength increases, so as wavelength gets longer, then what happens to frequency? Well, this is a high frequency wave, this is a low frequency wave. So as wavelength increases, goes from short to long, then frequency decreases. So frequency will decrease. So that's activity 2A. Make sure you know how to identify all the parts of a wave, understand that light travels as a transverse wave, and that you were able to measure all the different parts of a transverse wave.